following problems will not use any calculation. This is more about asking whether you have the correct concept of absolute maximum, absolute minimum, relative maximum, relative minimum. Okay, so first you have negative 3 to 3. So we're not considering the entire graph. We're only considering this graph on this closed interval, negative 3 to 3. First question is, what are the critical numbers of fx on the interval negative 3 to 3? Well, critical numbers are points where the derivative is equal to 0 or where the derivative is not defined, the points where the function is not differentiable. To get the point where the derivative is equal to 0, you look at points where you can have a horizontal tangent. So this is the point where you can have a horizontal tangent, right? It dips down and comes up. Okay, so whenever the graph changes from decreasing to increasing or increasing to decreasing, then at that point, as long as it's smooth, so you do have a well-defined tangent line, if it's differentiable and it changes from increasing to decreasing or vice versa, then that point where the increasing decreasing changes, that's going to have a horizontal tangent, right? So at negative 1 is where you have f prime equal to 0. Okay, so let's write that down. So x equals to negative 1 is one of the critical numbers because f prime is 0. However, there are two more points where the function has a critical number, critical point, and it's at negative 2 because over here at negative 2 there is no well-defined tangent line because there's a sharp turn. The tangent line that's tangent to the left side is this line, whereas the tangent line that's tangent to the right side of this point is this, right? This is tangent to this right side of the curve, whereas this is tangent to the left side of the curve, and they don't agree. And because of that, this point is considered to have a sharp turn, although it doesn't look that sharp, but it's considered as sharp. Any kind of abrupt turn, any kind of angle is considered as a sharp turn, sudden turn. And this would be a point where the function is not differentiable because it has a sharp turn or because it has an angle. Okay, so negative 2 should be on this list. And then finally, any point where the graph is not continuous is not differentiable. So right here, when it has a jump discontinuity, 1 is a point where the function is not differentiable. So 1 will be another point. So the answer is negative 1, negative 2, and 1 are the critical numbers for this graph. The reason being, at negative 1 you have f prime 0, at negative 2 the graph has an angle, so the derivative is not defined here, and at 1 the graph is not continuous, and any function that's not continuous will be not differentiable at that point, so 1 has to be included. Now, secondly, find all absolute extrema and relative extrema of fx on the interval negative 3, 3. Now, when you think about the relative and absolute, it's important to know that for relative extrema, you never include the endpoints. So, do not include endpoints. And this is actually a little tricky because depending on the textbook, some textbooks allow the endpoints to be included, and most likely those textbooks will call relative maximum as local maximum and relative minimum as local minimum. So there is some confusion here, but I am going to follow the rule that for relative extrema we do not include endpoints. The reason why I do this is because if I follow this convention, then some of the theorems are easier to state. And that's certainly how our textbook does it. Okay, so I'm just following our textbook. Okay. Now, for the absolute extrema, it's just simply highest point and the lowest point on the graph, and it may or may not be an endpoint. If you have an endpoint which is the highest point, then that's an absolute maximum. Okay, so you could have endpoints for these. Okay, so here this could be endpoint. Okay, so I guess this is easier. If you have the graph, finding absolute extrema is pretty easy. What's the lowest point? Right here, right? So this point right here is absolute minimum. So absolute minimum is at -1, -2. That's the point, -1, -2. Now what about absolute maximum? Well, where's the highest point of the graph? It looks like here, right? But now we have a problem here because the graph gets closer and closer to 2. If you approach from the left side, the graph gets closer and closer to 2, but it never reaches 2 because exactly at 1, the value is -1. The graph is broken and this is an open circle, so it just gets closer and closer to 2, but it never reaches it. Now in that case, if you have a graph where the highest point is just an open circle, in that case we just say absolute maximum does not exist, because you can't talk about the highest number or highest value of this function, because the function value gets closer and closer to 2. I mean, there are points where the function value is 1.99, 1.999, 1.9999. So it's something close to 2, but no matter how close you make it to 2, let's say, I mean, if you say, oh, I'm going to say 1.999 is the maximum value, but then you're wrong, because there's, again, another bigger number than this, which is 1.9999. And because 2 is not part of the value, we can't choose 2 as the maximum value. So in such a case, the maximum value does not exist. So absolute maximum doesn't exist. Okay. Now for the relative extrema, the nice thing about relative extrema is that it can only happen when it's on a critical number. Okay. So critical numbers are -1, -2, and 1. So we have -2, -1, and 1. These are the only points where you have to investigate whether it has a relative extrema or relative minimum. Now, relative maximum means that if you take that point and you go slightly to the left and slightly to the right, and you only consider this portion of the graph, you only take this portion of the graph, how does it look? It looks like, well, it looks like this and this, right? Now, if there's a small portion of the graph where this will become the highest point, then you say it's a relative maximum. If there's a small portion of the graph where you only look at that portion and this point is the lowest point, then you call that the relative minimum. However, for this one, there's some bigger numbers on the left and smaller numbers on the right, so it's neither the highest or lowest in this small portion of the graph. So in that case, we say this is not a relative extrema. Okay, so not relative extrema. However, this point, if you just take that portion and draw the graph, then this point here is the lowest. Indeed, it's the lowest in this portion, right? So in this case, this is relative minimum. Okay, and this third one is the most confusing one. When I said take a portion, I really mean that you should go a little bit to the right and a little bit to the left. So if you take the portion a little bit to the right and left, the actual graph that you take looks like this. It's like here a little bit, and then there's here. Okay. So in this portion, what is the nature of this point? Well, among all the values in here, this is the lowest, isn't it? It's lower than everything on this left side, and it's lower than everything on the right side, and therefore this point is the minimum in this portion of the graph, therefore it's a relative minimum. And we didn't find any relative maximums, therefore this is the answer. Relative minimum would be from -1, -2. So this point is actually both absolute minimum and relative minimum. And also this 1, -1, this point 1, -1 is another relative minimum. And there is no absolute, relative maximum. Relative maximum, again, does not exist. All right, since that was a little challenging, let's do another one to enhance your understanding here. Okay, this time you're taking the portion from -1 until 7. Again, to find the critical numbers, you're looking for the place where the graph has a horizontal tangent line, or where the graph is angled, or where the graph has discontinuity. Right? Okay, so and another thing about critical numbers is that, again, critical numbers are not allowed to be endpoints. Since our endpoint of the interval is -1 to 7, even if you see that at -1 the graph is horizontal, the tangent line is horizontal, unfortunately it's on the boundary, so this is not a critical number. So you have to be careful, okay? So the first critical number I see is over here, right here. That has a horizontal tangent line, right? So x equals to 3 should have f prime equal to 0. Critical numbers are where f prime is 0 or f prime does not exist, where the graph is not differentiable. Okay, I see this angle thing, okay? It's angled here, so what is this x value? Don't be fooled by this 1. The x value is 0. Okay? So 0 would be a critical number. Actually, let me erase that first. 0 would be a critical number. And then there are two discontinuities, right? Here, there's a jump discontinuity at 2. And here, this is R pod, right? When you have a circle with two arms coming out, that's called R pod, which is an acronym for removable point of discontinuity, meaning that this is indeed a discontinuity, and it's called a removable discontinuity. Okay, so you have at 5 a removable discontinuity. Anytime the function is not continuous, then it's not differentiable. So the function is not differentiable at 0, 2, and 5. 0 is not differentiable because it has an angle. 2 and 5, these are not differentiable because it's not continuous. The graph is broken at these points. And we also included 3 because at that point f prime is 0. Okay, find all absolute extrema and relative extrema of f of x on the interval -3 to 3. Oh, sorry, I copied over the previous one. Forgot to change. This should be -1 to 7. So what's the absolute extrema and relative extrema from -1 to 7? Okay. Again, the highest point of this graph seems to be 4, right? So absolute extrema or absolute maximum would be this 5, 4. Okay, on the other hand, absolute minimum would be this point right here. It's 3, -2. That's the lowest point. How about relative maximum? Well, again, we only need to figure out these points, 3, 0, 2, 5. So let's look at these points. Here, here, and at 2 is this point. At 5 is this point. We're looking for these 4 points, okay? Now, this is easy. At 0, you have something that's lower than the neighboring points, right? If you take this portion of the graph, this point is the lowest. So that would be a relative minimum. So let's write that down. 0, 1 will be a relative minimum. On the other hand, right here, if you take the portion left and right, the graph that you get is this and this, right? So this is bigger than any of these points, any of this graph, right? So since that's bigger than the neighboring ones, we know that the graph, the point 2, 3 is a relative maximum. Okay. I think local makes more sense. I like the word local maximum, local minimum. But since many books try to use relative max and relative minimum, I'll stick to this. Okay. You should know both. Some of the homeworks might have it as local max, local min. Okay, so now let's go to the next point. This point here, well, if you take this portion, this point is lower than the neighboring ones, so that would be a relative minimum, 3, negative 2. And this point right here at 5, well, if you take this portion of the graph right here, then the graph is like this with a point up here, right? So this graph has, this portion of the graph will have this point indeed as the maximum value. So this will be considered as a relative maximum. So relative maximum at 5, 4. That's how you do it.